Can you imagine an AI that can automatically do science? It can automatically think of unanswered questions and then plan out the methods and actually conduct different experiments until it reaches some scientific discoveries. Then it proceeds to write a full scientific manuscript from its findings. This might seem like sci-fi to some of you, but actually we're not too far from achieving this. So last week, this AI lab in Tokyo called Sakana released their project called AI Scientist. This is done in collaboration with the research lab at University of Oxford and British Columbia. And fun fact, Sakana means fish in Japanese. They call this AI Scientist the first comprehensive system for fully automatic scientific discovery, enabling foundation models such as large language models to perform research independently. And this might actually be one of the biggest breakthroughs this year. We might be right in the middle of the most pivotal time in human history. If there is indeed an AI that can automatically do science, we can expect an intelligence explosion. In other words, there will suddenly be an exponential growth in new discoveries, new breakthroughs that could change the world forever. Think quantum computing, space exploration, cures for cancer, solving climate change, or figuring out how to live forever. Problems that have been unsolvable, problems that humans have spent decades trying to solve. Well, now there's a chance that AI could just easily and quickly solve these problems. So in this video, I'm going to go over what this AI scientist is and why it's such a big deal. But before we go into Sakana, here's a brief history on how AI has been used in scientific research. Frontier models like GPT and Claude are already being used in science. So for example, here is an AI agent designed to automate the design process of gene editing experiments. Here's another AI that can design proteins that edit DNA. By the way, if you're interested in learning more, I covered these papers in this video where I talked about how AI is used for gene editing. So check out this video if you haven't already. Here, Google's protein predicting DNA called AlphaFold is helping researchers discover enzymes to break down plastic. And here, AlphaFold is being used to design a new drug to treat liver cancer. And earlier this year, Microsoft made an AI that can help scientists create more efficient battery materials. This would have taken humans over a decade to do, but this AI was able to do it in less than 80 hours. If you're interested in learning more, check out this video. Anyways, these AI systems or agents that I mentioned are very limited. They require constant supervision from humans. These AIs are only very good at a specific task, such as designing proteins for gene editing. If you take the same AI and drop it into an experiment to treat diabetes, for example, it's going to fail miserably. In other words, it's only great at doing a certain task, but it can't generalize across different scientific experiments. Plus, it can't do the entire experiment by itself. There has to be a human doing part of the work. Now, what if there was a way to take the human out of the equation? What if we could get AI to automate everything? It would design the entire experiment, it would fact-check everything, and it would actually conduct the experiment by itself and check the results, and if the results are not ideal, it would try something else until it reaches a significant discovery. And this brings us to Sakana's AI Scientist. Here, the authors describe it as a fully AI-driven system for automated scientific discovery applied to machine learning research. Now let's go over how this actually works. First, this AI is designed to automate machine learning research only. This is important because machine learning is the backbone behind all of the AI we know today. Machine learning basically means designing the systems and the algorithms behind AI. So it's not doing chemistry or biology or any other type of science. It's solely focused on machine learning, but that's actually all we need. We only need an AI that can autonomously do machine learning, and everything else will follow. More on that in a second. But here's how the AI scientist works. First, the human gives it a general topic, for example, language models. The AI scientist then starts to brainstorm ideas or questions about language models, and then it looks at how new these ideas are and if they've been solved already. It compares its ideas with what's already existing in the scientific literature. specifically in the Semantic Scholar database, to see if someone has already done this before. And if not, then it's a new idea worth testing. So after it has narrowed down on an idea, it then proceeds to do the experiment. It then proceeds to test out this idea. Again, since this is machine learning, everything is just digital. Everything is about data. So for the experiment, all it has to do is code everything up to run the experiment and then process the data and then look at the results. So after coding everything up and going through the experiment, finally it takes everything and formats it into a formal scientific article. So this is one of its outputs. So you can see it has a standard abstract, and then introduction, methods, results, etc. So these are the standard sections of real scientific articles. So it would write out like how it conducted the experiment, it would create tables on its findings, or even plot out some of its results in these graphs. It also automatically searches the scientific literature for relevant papers to cite throughout the manuscript. So as you can see, like throughout this paper, it's citing articles from other scientists. Now, in the world of science and academia, you can't just write something up and publish it immediately. It needs to go through a process called peer review, where other scientists rigorously review your work. Some of them might even try to replicate your experiment and make sure your results are correct and not made up. Now, the cool thing about AI Scientist is that it does this peer review process automatically as well. They've developed another AI which acts as a reviewer so that it evaluates the generated papers and makes sure that everything is correct. It also gives feedback on how this paper can be improved or what further experiments can be done. So this creates a continuous feedback loop where the AI can iteratively improve on its results and also create new experiments based on these results. It also adds what it has learned from these experiments into an archive of knowledge, so it can pull from these findings in the future if necessary. And this is very similar to how science works. In science, we have a huge archive of academic literature, and this is basically a database of knowledge that scientists can reference when they do new research. So in theory, this is a continuous feedback loop that never ends. This AI can go on and keep thinking of new experiments and keep trying to discover new things based on a given topic. And the crazy thing is, each paper only costs around $15 to generate, and this cost is used for compute and other resources. Whereas scientists in real life might spend months to years and spend tons of funding and resources just to come up with one paper. So this AI has sped up the rate of scientific discovery, at least in the field of machine learning, by orders of magnitude. Imagine if it can automatically design and test different AI architectures and algorithms, and all we have to do is sit back, relax, and wait for the results. I think this paragraph describes the significance of this really nicely. We believe this work signifies the beginning of a new era in scientific discovery, bringing the transformative benefits of AI agents to the entire research process, including that of AI itself. The AI Scientist takes us closer to a world where endless, affordable creativity and innovation can be unleashed on the world's most challenging problems. And this AI has already made several discoveries which they shared on their website. So I'll link to this page in the description below, but here it has discovered a new architecture for diffusion models. Diffusion models are basically used to generate images. And this is exactly what is used in Stable Diffusion and a lot of other image generators. It starts by taking an image of random noise and then slowly removing some of that noise at each step until it arrives at your final image, which you prompted. So here the AI Scientist discovered a new approach, which they called adaptive dual scale denoising. It claims that this can improve the quality of generated images. At a very high level, it basically balances global structures with local finer details using two parallel processing branches, one for the original input and one for an upscaled version. And if you balance these together, you actually get a better quality and more accurate image. Now, if you've been following my channel, you'll know that AI images are getting more and more realistic. to the point where it's really hard to tell apart. AI can already generate realistic hands and feet and various poses, as you can see in these examples. So now imagine if you use Sakana's AI Scientist to develop even better and more realistic diffusion models for image generation, and it can do this automatically. I mean, it already came up with this new approach. Very quickly, you're going to get image generators that are better and better, to the point where very soon it's going to be impossible to tell AI images apart from real images. And apart from image generation, it also came up with a new way to improve language models. These models understand natural language and are the foundation of GPT, Claude, and other state-of-the-art models. So here it developed a new method called adaptive multi-style generation, designed to help language models write in different styles more consistently. Again, I'll link to this page in the description below, so you can download and read the entire paper if you want to. It also came up with a new discovery in the field of grokking. So grokking is when an AI suddenly begins to perform well on unseen data. This happens when you train the AI on a dataset to the point of overfitting. In other words, it's kind of trained too much. You're excessively training it on the same data over and over again, but surprisingly, researchers have found that after too much training, sometimes it actually starts to generalize and understand the data at a deeper level. This is kind of like a eureka moment where the AI finally, quote unquote, learns something. So anyways, that's what grokking means, and this is quite an early topic. It's still not well understood, so this AI scientist came up with an idea to test how different weight initialization methods, or basically what the initial values of these neurons in the neural network should be before training, and how does this affect grokking and help the model learn faster. So again, this might take a normal data scientist at least weeks, maybe months, to do such a study and write up the paper. But the AI scientist can already pump out a ton of papers really quickly. So you can see like this isn't some vaporware. It has already produced some actual discoveries. And here's why I think this is revolutionary for AI. Currently, all the AI that we know today is limited by our current design of neural networks, which looks like this. If you're new to neural networks, definitely check out this video on how they work. Now, these are very inefficient and compute intensive, but unfortunately that's what we use today, and this includes GPT and Claude and Gemini. So all the tech giants are piling billions of dollars to invest in huge data centers to get more compute. They all say that compute and energy are the main bottlenecks here. In theory, we need more energy, more compute in order to create a more intelligent model, but I don't think that's necessarily the answer. Thanks to our sponsor, Wondershare Filmora. Filmora is a video editor loaded with AI features, and I personally use Filmora for all my YouTube videos. Their AI Copilot editing feature is super cool. You can talk to it like a chatbot and it would analyze your video and apply recommendations. Additionally, their AI text-based editing feature turns your video into a transcript so you can edit the video like a text document. Their AI audio tools are also amazing. You can generate music, remove vocals, denoise audio, and even clone your own voice. They also have speech-to-text, so you can easily create subtitles as well as text-to-speech for easily making voiceovers. They also have AI Smart Masking and Smart Cutout. This allows you to remove objects and change the background of your video in seconds. And publishing is also made easy. You can make thumbnails in seconds with their AI Thumbnail Creator, plus easily create titles and captions with their AI copywriting feature. Edit videos like a pro and save a ton of time with Wondershare Filmora. Try it for free today via the link in the description below. Instead of building huge data centers, which costs hundreds of billions of dollars, we could also just improve the architecture of these models to make them smarter or more energy efficient. In fact, there are already new designs being studied, such as liquid neural networks and spiking neural networks, which I've explained in this video, so check it out if you haven't already. But these are still in the early stages and there's no consensus on what works best yet. But what if we could get this AI scientist to actually improve these newer architectures, or even come up with a completely different design that is way smarter and way more energy efficient than what we have today? We don't need more compute. We don't need massive data centers costing hundreds of billions of dollars. Maybe all we need is a smarter design of AI models. And I think if we scale this up, if we can get this AI scientist to keep thinking of and testing out new designs for neural networks, I think we can expect a breakthrough in a short amount of time. Anyways, in the beginning of this video, I mentioned that this AI only does machine learning research. This is relatively easy to do because everything is digital. It only involves data and coding. There's nothing physical involved here. For example, it's not conducting like a chemistry experiment where it physically mixes chemicals, nor is it doing a biology experiment where it's conducting some surgery. So you might be wondering, well, it's not that great then. If this can only be applied to machine learning, then you're missing out on all the other fields of science in the real world. But actually, this isn't really necessary. Yes, this AI can only do machine learning, but if you think about it, that's all we really need. This is an AI that can design future generations of AI. As long as we can design something better, generation after generation, eventually we will get a super intelligent AI that can do physical science or be embedded in robots to interact with the real world. All we're doing right now is planting the seed. As long as this AI can design the next generation, which can then design the next generation, the rest will follow. It's a continuous and exponential growth. Another impressive thing about this AI scientist is that it uses existing AI models like GPT and Claude and open source models like DeepSeek and Llama. It's not reinventing anything here. It's not like using some revolutionary new model. It's just taking existing models that you and I have access to right now. And you can easily switch between different models. In other words, their system is model agnostic. It doesn't really matter which model you use, and you're not limited to using any specific model. And the really awesome thing about this is they actually open sourced it. So here it says they are releasing the open source code and full experimental results on their GitHub. So you might be able to actually go to their GitHub and clone the repo and actually run this yourself. Now they have a really hilarious note here. So here's what it says. Caution, this codebase will execute LLM written code. There are various risks and challenges associated with this autonomy. This includes, for example, the use of potentially dangerous packages, web access, and potential spawning of the processes. Use at your own discretion. Make sure you containerize and restrict web access appropriately. So I found this to be pretty funny. Please do not give web access to this AI because who knows, maybe it could escape and reproduce itself and all hell will break loose. After all, this is a continuous and never-ending loop. It continues to learn and do experiments and increase its knowledge over time. So if you give it access to the internet, who knows what would happen? Maybe it knows how to propagate itself throughout the internet, so even if you shut it down locally, well, it has already spread across somewhere else on the internet, and it will continue to reproduce and potentially cause chaos in the world. Now, I think that this warning is totally useless, to be honest. I'm sure that someone somewhere in the world will actually do this. They're totally going to ignore this warning and actually give this AI web access. I mean, do you really trust that all of humanity will be complacent and actually listen to this warning? But anyways, I'm kind of going on a tangent here. Basically, if you're a tech-savvy person and you want to get an AI to automatically do experiments based on a given topic, well, you can actually clone this repo and try it out yourself. Now, note that this is version 1. This is the earliest version they've ever released, so this is going to be the dumbest AI scientist you'll ever see. So it does have limitations. For example, it currently does not have AI vision, so it can't analyze any charts or graphs from existing literature. Plus, it sometimes makes fatal mistakes, such as thinking that one number is bigger than another, when it actually isn't. And this is actually a very common mistake and inherent weakness for LLMs. So I've used this prompt a lot to test out new models. What number is bigger, 9.11 or 9.9? And I'm using Llama 3.1 here, and you can see that it got it incorrect. It thinks that 9.11 is larger than 9.9. So you can see how this flaw could totally mess up the science experiment. At least for now, until this error is fixed, we still need humans to actually go in and try to reproduce its results and make sure that everything is legit. There are also instances where it tries to cheat the system. So in one instance, when the experiment took too long to complete and it reached their timeout limit, Instead of making the code run faster, it simply tried to modify its own code to extend the timeout period. So instead of trying to design a better experiment, it tried to change the rules of the game. So it's very smart, I must say, but in quite a mischievous way. And by the way, this isn't the first time I mentioned an AI that can automatically do science. So previously, I did a video on Google DeepMind's AI, which is kind of heading in the same direction. It's based on their AI called AlphaZero, which can beat the best Go and chess and shogi players in the world. AlphaZero uses an algorithm called reinforcement learning. It would basically play against itself for millions of rounds of chess or Go or whatever game you give it, and it would get smarter and smarter after each game. It would learn to develop its own strategies and eventually become world level at the game. It also uses another algorithm called Monte Carlo tree search to plan its moves. How this works is it tries to think through all the options to take now before deciding on the best path forward. So for example, for a chess game, based on the current state, it would think through many different moves into the future to try to find the best move to take right now. And Monte Carlo tree search is a very powerful algorithm that's not just limited to board games. The same framework can also be carried over to scientific research. So AI can use Monte Carlo tree search to come up with a ton of different ideas on how to approach a scientific problem at each step, and then choose the best path forward. Now, it's also rumored that OpenAI's mysterious Q-Star project, which is also called Strawberry now, works in a similar way. It's supposed to be their top secret super intelligent AI, and it also uses Monte Carlo tree search to look at all possible scenarios before deciding on which path to take. So this is very similar to what Google is creating as well. But right now, everything regarding the Strawberry project is only based on rumors, and I don't like talking about something that hasn't been officially announced yet, so I'll just leave it at that. Anyways, that sums up all we know about Sakana's AI Scientist and other AI models that can autonomously do science. As soon as we get an AI model that can truly and autonomously do science and discover things on its own, then the rest is history. We don't have to do the thinking, we don't have to do the design, all we need to do is feed it compute and energy, and it would go off and learn about the universe for us. You can expect to see an intelligence explosion very soon, where we have an exponential growth in scientific breakthroughs. We're going to start seeing very hard problems being solved, like nuclear fusion, or reversing dementia, or even maybe finding a way to live forever. All of these things could very well be solved within our lifetime with AI. We're living in a really exciting and pivotal time right now, so buckle up and try not to die. Let me know in the comments what you think of all of this, and how soon do you think we can see this intelligence explosion? As always, I will be on the lookout for the top AI news and tools to share with you, so if you enjoyed this video, remember to like, share, subscribe, and stay tuned for more content. Also, there's just so much happening in the world of AI every week, I can't possibly cover everything on my YouTube channel, so to really stay up to date with all that's going on in AI, be sure to subscribe to my free weekly newsletter. The link to that will be in the description below. Thanks for watching, and I'll see you in the next one.